Good afternoon, morning, evening, night. Thank you everybody for joining. Looks like it has just gone live now, so you didn't hear my funny or not funny intro. So thank you everybody for joining. We are doing our first 2-pint webinar. So thank you for being guinea pigs and thank you for taking time out of your day to do this. We know that Windows 10 is kind of becoming the thing sooner than later. So I wanted to give you a little bit of information about how 2-pint can help with that and to really help you understand all of the different peer-to-peer technologies that you have to work with while you're going. So I will get started. If you have any questions, by the way, we do have live Q&A. We also have a Twitter stream that you can follow. So you can post your question in either place, and then we will try to do the webinar winner at the end of the presentation. Okay, here we go. We are 2-pint Software. I am Amy Ardmark. I'm one of the courts of 2-pint Software. I will let another court and 2 other pints introduce themselves as well. So guys, go ahead and say hello.
All right. My name is Andreas Hammarskjöld. I sit over in Sweden and is one of the co-founding partners of 2-pint Software. And with me on the call, I got 2 other people who are
Phil and Phil. So I'm London Phil. I'm the other co-founder of 2-pint Software, sitting in rainy London town.
And I'm Aussie Phil, sitting down under in the middle of the night, obviously based in Australia.
Awesome introduction, guys. So a little bit about us. We are all, I think, at heart, config manager admins. We have at some point used the product directly, starting off in the beginning, just like everyone else. And I think we've each taken our careers in different directions, and then we've all ended up together. But at the end of the day, we still care about who you are and what you do, and we care a lot about helping you get content distributed in a good way, and in not taking down the network and not having the network team blame you sort of way. Some of us have worked with it from the very beginning, and some of us started in more recent years. I won't reveal anybody's age, so you can guess who has more experience than others.
Thanks, Amy.
You're welcome. So we have a very loose agenda. We like to pretend like we're structured, but we're not. So this is how things are going to go. Try not to make it too marketing. Obviously, we are 2-pint, so we will talk a little bit about ourselves and how we can help. But really, we want everyone to understand peer-to-peer technology itself. So rather than divide it up into them versus us sort of webinar, we're going to talk about all of it all at once. You may find tips and tricks while we're talking about the technology. You might find it after if you need to interrupt and ask questions. Obviously, we're watching that question stream as well, so we might jump in. One of us might interrupt the other while they're talking, and then Q&A at the end as well, and drawing the webinar winner. So without further ado, here we go. I had tweeted a little bit about this sort of leading into the webinar this morning, talking about peer-to-peer technology, specifically branch cache and peer cache. But what I think we all want everyone to understand is that no single peer-to-peer technology relies on the other, meaning you don't have to enable branch cache if you want to use peer cache. You can turn off delivery optimization if you want to, and still use peer cache in config manager, for example. But they all are, in a way, really good together, and they can help extend how you do or how you think about traditional content distribution, such as using a distribution point to spread content. So then a brief overview before we really get into it. Branch cache is for on-prem. Delivery optimization is for cloud, and this is new for Windows 10. And we'll definitely dig into this and what you need to know around delivery optimization. And then peer cache and config manager is for config manager content only. Guys, is there anything you wanted to chime in before we move on?
Any questions? That's it. No, that's about it really. But I mean, we will go deep in some places, and there'll be a bit of crossover because There is crossover like between branch cache and peer cache, and a little bit between branch cache and delivery optimization. So stay with us, and this will be downloadable at the end. So if you miss any bits or it gets a bit too technical or not technical enough, stay with it, and we'll try and guide you through.
Sounds good. All right, here we go. So as I said, delivery optimization is new with Windows 10, and this is more cloud service, cloud enabled, because this isn't going to be dealing with your config manager content quite yet. There is a roadmap for delivery optimization and config manager working together, but this is for dealing with store downloads, Office 365, and settings within Intune. So who's using it today? Well, I got news for you. Unless you've blocked it, you're all using it. Please don't block it. Just do the full slide. Yeah. So don't block it. And this is something that you can see even on your consumer devices if you go into settings. And you can decide whether you're peering within your organization or if you're allowing devices to peer with other devices on the internet. Microsoft is making a push to have all components going towards delivery optimization. If you paid attention to any announcements at Ignite, for example, then you would have heard that DO is available for Office 365, Windows Update, drivers, etc. Then you start to think about, well, why do I care about delivery optimization and if it's turned off, or why would someone go and turn DO off for an enterprise? Well, you have to think about two sorts of stories when you're moving to Windows 10. The first half of the story is how to distribute all this content, and this is what we'll get into with the other technologies that's needed for Windows 10. So your boot WIM, your OS image, any applications. But what people aren't thinking about is what happens after that first login. Does peer-to-peer stop at that point? And the answer is no, it really shouldn't. For two reasons. One, because you might be running more actions in your test sequence after a computer is logged in. And second reason is because there's actually additional downloads that happen where a device is reaching out to a Microsoft CDN to get more content. And that is the updates that happen to applications after a user has logged in for the first time. So with 1703, we're looking at 1.3 gigs of download per PC. After a deployment, 1809, 1.4 gigs. So with each new iteration of Windows, we're seeing a little bit more download after the fact. We good there?
Yes, I'm just
okay.
reading the Q&A,
Okay.
but there's nothing yet.
So again, DO is a cloud service. So it reaches out to a cloud service, your device does, to say, this is where I am, who's near me that has this app, this download, this whatever it is that I'm requesting. It can download from multiple sources, so it can download from a peer, or it can reach out to the cloud service for a download, and it can run it in parallel, and it's quite fast. And of course, we do have a little bit of a roadmap. I'm not quite as well versed in delivery optimization as my coworkers, but again, there were quite a few announcements at Ignite, and now that we're in spring of 2019, we already know that we can configure DO settings within Intune. Applications pushed out via Intune Win32 apps are available for DO, and as well as Office 365, and then we'll start seeing more of that in Config Manager going forward. Phil, I believe this is something that you're always talking about behind the scenes.
It's me. So this was basically based on some testing that we were doing in the last few days. So we do a lot of testing, and we work quite closely with the DO devs. And what you can see here, and there should be some headings above them, but it doesn't really matter. The one on the left is the first client on a subnet or a location to download. So in the previous slide where we mentioned that There's lots of content that comes down once you've built a Windows 10 machine. This is kind of the results of that. If you just let it do its own thing. So the one on the left is basically a machine that doesn't have any content, doesn't have any peers because it's the first one on the subnet. So if you think of it in terms of you're doing a migration, you've got 100 machines in Windows 7. This is the first one that's actually come up, and it's maybe an 1809 build, and this is what you'll see. It's going to download about a gig or a little bit more within a few hours of completing. Now you can do certain things about that. Obviously you can remove some of the built-in stuff, but it will still pull quite a lot of content, and the reason for that is that once Windows is up and running, it goes, oh, okay, do I have the latest and greatest version of everything? So it looks at all its features and all of its built-in applications, store applications, and it updates everything that isn't up to date. So that's all good. And then on the right-hand side there, this is the second machine that came online. Now, you would think that in a peer-to-peer scenario, because the content is on machine number 1, machine number 2 just goes, oh, hello, I need some content, give me a list of peers, and then gets all the content from number 1. But as you can see on the right there, it's only actually got about 1% from peers, which is not great. And we just wanted to highlight this because we've seen this behavior out in the wild, and it can happen. And obviously, it's not ideal. We've been talking to the DO team, and they're working on it. And the thing with DO is that there are a ton of settings that can be tweaked, and we're experimenting with the best ones in order to kind of get some really good metrics so that the DO team can tweak their end of things and also provide guidance as to what you guys should be doing on your end of things via either group policy or in tune CSPs, etc. So the thing to remember is that DO is a live cloud-based service, and there is a lot of things that they do on that end to tune that, and they're constantly tuning things. On our end of things as users and administrators, there are things that we need to configure correctly. So we can set things like the maximum age that stuff stays in the cache, the minimum file size that's required to do peer-to-peer. I think there are, in the latest insider build that I looked at yesterday, there are now 27 policies that apply just to delivery optimization. So that's one of the things that we do within our kind of add-on solutions, is that we manage all of that. But it's still relevant to understand what all of this does. We're not going to dive into the whole kind of 27 policies one at a time, you'll be pleased to know. But really, it's just to highlight that you can't just roll out delivery optimization, configure a couple of settings and expect it to all hum along and behave nicely. And when it doesn't behave, obviously the impact of what you're seeing in this slide here is pretty much double the WAN impact. So instead of a gigabyte of content coming down and then the other guy's getting it from the first one, then the second guy is downloading a gigabyte. Potentially the third and the fourth guy might be downloading a gig as well. And if you've got 99 other Windows 7 users still trying to do their work, then that might be a bit disastrous. So the DO team just sent us an email just before we came online, actually, just to say that they are looking and they're really committed to tuning this. And so it's good news, really, because they're starting to really understand the enterprise scenarios that we work with every day. So that's it for that slide. I think you can go on to the next one. Do you want to talk about this one, Amy, or shall I carry on?
Carry on. Go ahead.
I have no idea what this is.
So this
Only
is
joking.
in Windows Analytics Update Compliance. So we do have a way, especially if you aren't using Config Manager and you aren't sure the weight that DO carries in your organization. This is in preview. You can see the delivery optimization status in your organization. So a lot of times people will say, I want to use peer-to-peer, but how do I prove that whatever technology I've proven is working? Well, now within your Azure portal, you can see your delivery optimization stats here. So it's pretty similar to the client data sources dashboard that you would see in Config Manager, except you're seeing it here in Intune. I don't know if there's a roadmap to put this same information within the Config Manager console as well. I hope that there is, but this is what we have right now.
I think that there is. Well, it's been talked about. You can configure some of the settings that you require for this within Config Manager. And obviously the whole this dashboard itself has moved about quite a bit in that there's obviously you've now got the new desktop analytics stuff. So there is a big push to make these stats better and to make them more accessible. So it makes sense to put them, I would say, either into the management insights within Config Manager or into within its own dashboard.
Yeah. Slide doesn't want to move forward. There we go. Demo time.
Ooh,
I'm going
okay.
to stop sharing and allow you to share so you can demo.
Thank you very much.
So attendees, there is a bit of a pause. So I'll make sure Phil doesn't start talking before he's sharing.
Yeah, let me know when this comes through. Okay, I'm gonna share my desktop.
Should be there. Maybe someone in the chat, if you can chime in and see when you can see it, or say when you can see it.
I can see it down under.
It's made it all the way to Australia.
Awesome.
Anyway, I'm going to start talking anyway. So this is just a little kind of to get you started, really. Look at some of the PowerShell commandlets within delivery optimization, because what you might want to do, and what is actually quite a good idea, is to start testing this in your labs, or if you don't have a lab, just do it in production like everyone else seems to do these days. But it's really just to get an understanding of what's available, and DO is a little bit tricky to kind of troubleshoot and to measure, shall we say. So you want to know if it's working correctly.
Who unmuted Phil?
Someone muted me. Who did that? Who would do such a thing? Can you hear me now?
I can, yeah. I don't know
How
what
rude.
happened.
How very rude. Okay. So we've got logging. I'm going to start with actually status. So get delivery optimization status is kind of your go-to. And as you can see there's nothing actually going on. So it's like, well, how can I test this? And this only actually works if there's something running. So what you can do is you can download something from, and I'm just going to try to download something. I'm going to download this game because games are quite a good way to test things, because there are about 100 meg, a lot of them, so it's not too big. So I can actually start downloading this. But what you would have to do is to just keep running that little commandlet until it started showing some data. So if I run it again, quite often you get an exception, but there we go. They do actually fall over quite a bit, these commandlets, but mostly So we got some information, but obviously you don't want to have to keep running that, and it's not very nicely formatted. So there's a little snippet here which basically will reload itself every 3 seconds. So it tells you the file size and what the status is and the priority. So in DO we have foreground and we have background. Foreground is your Windows Store apps, user initiated, basically, and background is stuff that updates itself, like your Windows updates and all that kind of stuff. Maybe, you know, Office 365 or Intune, Win32 apps. So that has quite a bearing on how much bandwidth they use as well. So it's important to recognize the difference. So you can see here it's chugging along nicely. It isn't really on any other computers, so we're not seeing any peer-to-peering, but this is quite a useful little snippet of PowerShell, and it's just an example. And there we go. You see it's just kind of crashed, as these things do. But what I will do is we now have a 2-pint GitHub repository. So all these snippets that you see today, don't worry about trying to remember them or write them down, because they will be posted later. Okay, so the other one that's worth noting is Get Delivery Optimization Perf Snap. So that will give you a little snap of bytes downloaded, uploaded, etc. Average download side. Not very interesting, but then you have a slightly longer version of that, snappily titled Get Delivery Optimization Perf Snap this month, because it compiles the stats monthly. So that gives you a little bit more. So you could, for instance, if you wanted to, you could, in Config Manager world, you could create a CI, for instance, run this PowerShell to populate WMI and collect this via hardware inventory, and then you've got a kind of built-in, you know, reporting mechanism. So you could start to create reports around this, and you can see how DO is actually peer-to-peering. And the other thing to, once you get deeper into things, is the Get Delivery Optimization log. Now, if I just run this, it will probably take a long time because the logs accumulate over time. So this machine hasn't been built very long, so it's not really taking too long, but it can take an extraordinary amount of time. So what you can do is run this little snippet. So you can say, oh, I only want to look at the last log file, really, and I'm going to do a little bit of formatting, and the wind's blowing in the right direction, then it should take a little bit less time to run. And in here, you get some pretty interesting stats. So this is where you can start to troubleshoot things. And you probably wouldn't know where to start when you first look at this, but once you've been around it for a while, you'll soon get to know. And we're going to blog some of these key points in here as well, so that you can get started pretty easily. So for instance, I had a warning towards the bottom there that said, failed to get even one piece. That doesn't sound good, does it? So it's a good way of highlighting when things are not going well. Other things that you to look out for are hash failures, hash mismatches. You can do things like check whether DO is actually using a group ID. You see here it isn't because I don't have one set, but the thing to remember here is that if you do set a group ID within the log files, it's actually encrypted. So I don't expect to see the group ID that you see in the registry or in GP edit, etc. So you can search for keywords, obviously. This is a good one that cropped up today. And what this is DO uses an algorithm to decide when it's time to get rid of stuff in the cache. And one of the issues that we explained earlier around bad peer-to-peering can be a result of this, and it's where DO is using aggressive algorithms to work out when it should expire stuff in the cache, and that's what the DO team are working on right now. So hopefully that makes sense. I think it's time maybe for a little bit of branch cache Bob.
Sounds delightful. Let's see if I can manage to share my screen. Wondering if we can actually manage to do a complete webinar where we don't actually leave any consoles. We only do the whole thing in the consoles. So
Yes, one day.
I think we see it. So what we're going to use today is we're going to talk about branch cache, and together with branch cache, typically you as a configuration manager or a system administrator deal with that in the integration of bits. So bits is the actual downloader, and branch cache is the peer-to-peer technology that's managing the peer-to-peer side of things. So often what we deal with is how does it actually work? Why is it not working, etc. So obviously we built tools in order to manage and analyze this in real time. But I wanted to dig into how does branch cache actually work and which components is using it, etc. So we're going to use a little tool that we built that we're releasing, or it's kind of re-releasing of a branch cache reporting toolkit that had some nice features that we're going to look at. If you run the tool by itself, you'll be able to see that it squirts out quite a lot of different command line options that you can run with it. You can simulate bits traffic all together, make sure that the traffic runs between two different hosts, etc. You can also analyze the bits event log to see what type of traffic and peer-to-peer ratio have you managed to get over time. You can run this per machine in order to get that stats, and you will see which jobs are not actually peer-to-peer very well. So it takes quite a long time to run. I have quite large lists of bits jobs, but here you can see we basically take all of the bits events jobs that's been running on this machine and compare the different types of them and give them the different download size and the ratio. So this is one of our dev machines. So you can see that lots of unknown test jobs that we create. You can see the download size, which is 35 gigabyte, and the actual peer-to-peer ratio of that is 14 gigabytes. So obviously that's not too good. But how does branch cache actually work, and what makes these figures look the way they are? So in order to look at that, we'll switch to a different set of viewings. So one of the things that we can do with the BCMon tools, we can actually dump out information in what's called a configuration or configuration information, a CI. And the CI is basically the list of hashes that branch cache is using to find content on other peers. So in order to start simple, because it's key to understand this in order to figure out why branch cache is working the way it is. So I have a little file here, it's 104 bytes large. And if I run the BCMon tool against it to dump out the information, you will see that I ran it against the wrong file. What I wanted to run was this guy. So let's start over. So this is the 104 byte large file. You can see what it has is some segment hashes and some segment secret, number of segments, where they start, and how big, what part of that file is basically represented in that segment. So we're going to get quite technical on this. So I can add to the command line to basically dump out the full CI. And here you can see that branch cache has created a segment hash, which is 32 bytes long. So that's what that represents. So this is a single little chunk of data that branch cache, if it wanted to find information, it would send this out on the network and get the content back. So obviously, that would be a single file, which would be 69K large. So if you wanted a slightly larger file, we could look at a one here. That one has 54 segments in the actual CI file and represent a total of about 5 megabytes. You can see there, 5 million bytes. So obviously, the file is going to be bigger. So if we run this against our boot WIM, which is the CI that represents a boot file, we will see that it's quite a lot of these segment hashes in the file. So this represents about 400 megabytes of data, and it's broken into 5,000 different segments. So that's pretty a good way or start to understand. So when branch cache wants to download something, it downloads this tiny file before. And as you can see, it's about 300K. So typically branch cache goes, the hashing goes between 1,000 to 2,000 part of the data that you want to download. So if we want to see this live in action, we can actually use the same tool, but with a different set, and we'll attach it to an actual branch cache job. And we'll see that in real time as it's downloading, and we will be able to give you the output on the screen. So what I'm doing here is I'm creating a bits job, which would be what happens if you run something in the software center. I'm going to put that into my real-time command line option. So that's going to start looking to see that that job is running, and I'm going to kick that off. So then what you can see is the job is basically starting to download, and the gray parts indicate that all content comes from the server. So hopefully your screen will be, you guys' screens will be able to show this, but you can see here as the download progresses, it will get the content typically more or less 100% from the server. There's some little red bits which indicate that there are other elements on the network that it found. It basically means that it found a couple of these segments that we saw in the other command line option. And as it found those, it pulled them down. And of course, then when it's downloading, it will put all of these segments and the data into its own database. That's how it's kind of like Internet Explorer, caches files. So we cache all of the segments and the identifiers. So if we're to run a download of an updated file, let's say you as a configuration manager admin update your boot WIM, you add a driver to it, which is actually what we've done in this example. We'll get another bits job, of course, that we want to follow. So before I kick that off, I'm going to update the job here. That's going to start waiting for the job to finish. And as that continues, you'll be able to see that there's not a lot of gray. And actually, in this fact, there's no gray more or less whatsoever. You can see, if you got good eyes, you can see that we did pull down about 56K in the beginning from the server. And that's because this is a WIM file. So the XML header in the beginning of the file is different. So because that's just says how many files and how big the WIM file, etc. is. So that's different. So that had to be pulled down. But that was probably typically in a single segment. All other data is coming from its own cache because it's already been downloaded before, until we reach the end of the WIM file, where we'll see these bytes from server slowly start getting a little bit higher. And that's because that's where the DLL or the driver files that we see, you can see that's going up currently to probably about 1.4 meg, which was the size of the driver that I added. Does that kind of make sense?
Yes,
silence.
perfect sense.
So, and then we'll do a second demo. We'll probably go back to the slides a little bit, but there are a lot of capabilities within this tool itself. Others that you can play around with is actually to listen on the network by doing the probe match command, which allows you to basically sit and listen and look at these probes as they fly around on the network. You can also simulate probes and send them out as you by yourself on the network. So it's quite a nifty little tool to use.
And the reason that you would want to do that is because one of the reasons why branch cache might not work sometimes is because these probes are being blocked at the network level.
Yes. So working with large customers, there's a lot of different settings that they have set in their, let's call them security baselines, etc., that has completely or made branch cache not work. So it's a good element to actually play around with. So we can go back to the slides, Amy.
Do you see them yet? I've resumed slideshow in Teams. Let's see if I can just do it again.
Is this where we do the little sing and dance routine?
Now, there we go.
There we go.
Perfect.
Yeah.
So as we mentioned, the hashing of Windows 7 is different than the one on Windows 10. They're really worlds apart. That doesn't mean that Windows 7 is bad. It just means that Windows 10 is even better. So we'll be doing a little demo later where we'll downgrade my machine to a Windows 7 level, and we'll rerun the same test as we just ran to look at the difference. So this also comes into play if you're using our OSD toolkit to deploy things. There's an element in there which basically, if you're deploying Windows 7 actively, not that anyone be doing that, since it will be supported for about 200 days. But if you were, you probably would like to downgrade within the OSD toolkits, etc. And there's a blog coming that will describe that. But your Windows 10 machines can still create Windows 1 content and to respond to the Windows 7 machines if you wanted to. So ultimately, if you're running two versions side by side and you're not using any of our tools, you can actually run our free injector scripts after you're downloaded on Windows 10. You then run our injector script to inject Windows 7 media or inject Windows 7 hashes into your machines. And then when the 7 machines come to run, they will basically get the content from the Windows 10 machines. Because otherwise you will get two downloads, one from 7 and one for 8. So there's other aspects where branch cache is pretty good. Is also if you want to do different injections. So one type of injection that you can do is actually if you have really poor WAN capabilities and we're dying to get the latest Apex, basically a lot of the stuff that comes down via DO after you built a machine, you can actually create a package, sideload all of your Apex content into those via the Windows Store, or use the config manager store integration, put them into a package, sideload them, but basically you're peer-to-peering them using branch cache and injecting them into the machine. That way, when DO wakes up and kicks in, the other aspects and basically the store and the other components will not go out to grab so much content. So that's a good way if you need to get around DO pulling too much after you built the machine. Or on a frequent basis as well, you could pull down every night more or less and redistribute it out in your environment. Because it will only pull down the deltas, which was going to be pretty tiny using branch cache. So I think that's then, after that slide, we're going back into our demo again. So let's see. Hopefully you guys can see. So what we're going to do is I'm going to go into modify the way that bits and branch cache integrates together. So there's a, in the branch cache policy or local group policy, you can actually downgrade a machine. You're saying it's going to be on the Vista or bits 4, but it was just the Windows 7 version. So if you apply that, then basically when the machine goes up to the server, it's going to say, hey, I'm a Windows 7 machine, so I need to talk version 1. And as it does that, it's going to look slightly different. So in order to not fool everybody, let's see if I can go back to my. So in the previous run, we're going to download exactly the same 2 files. You see that the difference here is 99.62% came from branch cache on the Delta, right? So we downloaded 1 meg in using version 2. So let's see how version 1 performs. So I got a different grid that I want to follow. So I'll go and get that. And then kick off my job. Go back. You can see, since I cleared the cache, everything's coming from the server, right? More or less, absolutely nothing comes from branch cache. Make sense? All right, let's see if my demo works. So I created a second Delta job, which is a different type of file. Or it's the same file with the updated driver, basically. Let's see how that performs. You can see it's going a little bit slower. You can see here in the, if I zoom in, basically see that it's probably trying to find content, but can't, moving fairly slowly. And you remember I said in the Delta in version 2, it was only 56K because the XML was different. In version 1, the hashing is based out of 32 meg chunks. So if the first 32 meg is different, it means that the Delta is going to be pretty bad. So basically the first 32 meg is all going to come from the server because there was a single little tiny change in the XML at the beginning of the header. And once that's done, probably what we'll see is that the rest comes from the actual branch cache source. And since this is a WIM file, the Delta is still pretty good. But if all of your files that you're distributing were less than 32 megabyte, it would mean that branch cache would always see that as a full change and pull down the complete content. So it's a good way, it's a good method to, when you're distributing content and using version 1, to make sure that you're always have a large single file. So as you can see here, now the Delta that's being pulled comes all from branch cache. And there's only exactly the 32 meg chunk in the beginning that basically came from the server. So the answer is how much worse is version 1 than version 2? The answer is it really depends on how you're distributing things and also how you package things. So don't be afraid to put all of your 5,000 files that you have in your source package, put them in a zip file. Branch cache is very good to find the actual Delta. And here you can see in the end, branch cache is pulling all the gray bits, where earlier it was only 1 megabyte. It's actually a lot more because the single changes will then basically take the 32 meg chunk and say, hey, I need to download this full 32 meg chunk. So it should hopefully finish here within a second, and we can see what percentage we're getting. And don't know if you remember, but the first file pulled down 1.4 meg. This version 1 pulls down 45 meg, and it takes the ratio down to 87% compared to 99.6. But it gives you a pretty good understanding. Version 1 is not at all something bad, but it works very differently on the chunking mechanisms. So I think that concludes the second demo. So we can probably go back to the slides.
So Andreas, is this tool going to be available soon for people to
It is,
download?
hopefully later today. And I'm sure there will be lots of bugs, but it doesn't actually change anything. So any bug will be quite not very dangerous. So it should be all good. So yeah, hoping to put that on the website as well.
Cool.
All right, back to the slides. Can you guys see the slides okay?
Yes.
Okay.
As I mentioned, there are some issues that can happen, or maybe we didn't cover that, but branch cache has been around for many years, 12 years now, I think. So it's pretty mature. There are, of course, things that have broken over the time. One of the things that's been floating around on Twitter the last couple of days is where the cache size on clients doesn't shrink as it should. Hopefully that's been resolved. There was some fix that went into the March CU for 1809, and that's, as far as I know, being backported down to 1803 and maybe not 1709. I don't know. Otherwise, things that comes into play around it is Windows Defender and other third-party antivirus that holds files as they're being created, or which can cause some issues. So if we jump to the next slide. Here's an example as what we've seen on the server side, which will hopefully got the Microsoft support team acknowledged as well, is where the server, some random occurrences, stops responding with the peer information to clients. So when it does that, of course, the client doesn't get the right peer-to-peer information, so it can't peer-to-peer. And basically it stops, it just does regular downloads, which is not great. So, but you can find these if you're monitoring for event 13 on your distribution points. You can actually capture this and take actions on it. So moving into peer cache peatland.
Peer cache Pete. I know this is your favorite.
Who's Pete? And who's Doris, by the way? And who's Bob?
Well, it makes it easy. I think Amy's the best person to explain this, because you know it's International Women's Day today. So
oh yes, it is.
It is, and Dio Doris is a very, very strong female character, obviously. I think she should explain exactly why she came to be and how.
I actually don't know the history of why we have these characters, but I think it's really great to be able to explain the differences between them.
I think
through
it goes
visualization.
I think it goes with that. People can't remember anything, but what people can remember is actually good stories. So if we make a good story about the differences of these technologies, and we put it into characters so that people can have something to visualize. Like Branch Cache Bob is this slightly older dude, has been around, very reliable, gets the job done, etc. Delivery optimization Doris is a woman, and she can basically multitask. Branch Cache Bob he can multicast or multitask, but basically Bits, which is almost Bob's uncle, he's not so good at that. He likes to do one thing at a time, which is kind of the mentality. Doris is more of a female. She does everything at once. which is also what people sometimes complain about, that there's too much going on through the network. And PeerCache Pete is this guy, which is not really a peer-to-peer technology. It's a client-to-client download, but it's very efficient when he's got his mindset right. So, but maybe a little bit simpler than these two advanced hashing mechanisms, but definitely gets the job done depending on what you want to do. Does that answer the question? Hopefully.
That's a great answer. I will go back to the Pete slide. Okay.
So who wants to talk about Pete then? Nobody. Oh. Okay.
I'm stuck in the answering question channel.
Okay, then you take some questions and I will introduce Pete. So PeerCache came with Config Manager. Actually has been around longer than you might think. It came around in about 2014, I think. And originally it was only in WinPE, and it was called WinPE PeerCache. And so as Andreas kind of alluded to, it's not really what we consider a true peer-to-peer technology, because a peer-to-peer technology, as we see it, is really a mesh where everything kind of spreads out organically and the peers are chosen dynamically. So the way to think about PeerCache really is it's more of a dynamic distribution point. It's kind of, we say dynamic because obviously if they're workstation based, they can be switched on or off, or they can move around even if they're a laptop. So, but it's still a distribution point in terms of when you look for content, you get back a list. When a client looks for some content like a package or an application, then it gets back a list of content sources. Now, historically, that was always just a list of distribution points. And these days, it can be a mixture of distribution points and PeerCache sources, which from here on will be known as super peers, because that's what they're kind of known as under the hood. So if you think of a peer is something that's downloading, super peer is the one that's doing the sharing and hosting the content. So it's good in some ways, not so great in others. So we're going to go through the list. It works with any config manager client, and that includes XP. And believe it or not, there is still quite a lot of XP out there. So if you're in a mixed environment, for instance, you've got Windows 7, you've got Windows 10, then PeerCache just works seamlessly across those different OS versions. And as Andreas explained earlier, with branch cache, you do have to consider the V1, V2 scenario. Windows 7 works slightly different to Windows 10. PeerCache a lot simpler in that respect. One of the downsides is that content, and one of the main things to remember when testing this is that content must be fully downloaded before it can be shared via peer-to-peer. So we think of it in terms of currency. The currency, the item of currency for branch cache is a block of data. Okay, so branch cache doesn't care about files or packages or programs. It operates at a very low level. The unit of currency for PeerCache is a piece of config manager content. So it's either a package or an application or a software update, etc. And the whole of that content must be in the CCM cache before it can share it out to other peers. Very important to remember. Uses bits as the download mechanism. So just like branch cache uses, bits is the main downloading kind of engine within config manager and within Windows for a lot of things, config manager and outside of config manager. And that's the case with PeerCache. But obviously with PeerCache, a bits download can be a download from the distribution point. It can be the super peer caching it from the distribution point, or it can be a peer downloading from a super peer. it's still a bits download. So branch cache doesn't come into play. So it's important to remember that it is just a point-to-point bits download, which makes it in that sense it's very, very fast, and that's what makes it pretty quick. So it's basically a web service. On the superpeer end of things, there's a web service that starts up on the client, and it shares everything that's in the CCM cache. So if you have a machine that already has gigabytes of content in the CCM cache and you turn on peer cache, then it will report that back up to the config manager database, and that becomes available for sharing. So it's very different to the way that delivery optimization or branch cache work, because it relies on several moving parts. So the client has to report up to the config manager database that it has this content before it can share it. So there is an overhead on the database, obviously, and you need to consider that when you work out how many machines you want to turn into super peers. So there's a bit of an equation to be done there. The reporting is pretty good. It reports results back to config manager. And the client data sources dashboard in there is the place to go. It's under the reporting node, but you can then look at the results per boundary group, and it's pretty good. Good way to get started when you're testing. It works during OS deployment. There are things you have to configure. It's kind of admin heavy, as we said at the start there in one of those early slides. Each of these solutions has a different admin overhead. Peer cache is quite admin heavy because there are a lot of moving parts that you need to remember to configure correctly. So for instance, during OS deployment, you need to make sure that you set some collection variables on the collections that you're targeting, because that then gives the peer cache client a token that enables it to get content from within WinPE, and if you don't have that, then it will fail. Works with content, config manager content only. It can't at the moment do things like policy, scripts, etc. I don't know if that's planned, but that's how it is at the moment. But that can be done by branch cache. So some best practices I will just fly through quickly. Probably the top one that you need to do is select your super peers carefully. If you turn on peer cache and make everything a super peer, and the way that you turn it on is in client settings, in case you didn't know. So it's a client setting, and then you deploy it to a collection, deploy that setting. And you need to be careful that you don't deploy it to too many, because obviously all of those super peers need to report back to the database. So then there's a database overhead, etc. So we recommend that you use a query-based collection based on things like chassis type, disk space, etc. Make sure that you've got your beefiest machines with the biggest disk space as your super peers, and everything will be fine. If possible, static machines that don't move about too much, because moving on to the second point there, boundary groups define the peer-to-peer scope of peer cache. So peer cache will, by default, peer-to-peer within a boundary group if it's turned on at the site level. At a more granular level, you can also specify that within a boundary group, peer cache will only serve clients on the same subnet. So you can make it behave a little bit like branch cache as well. But in order for it to work properly, really, you need to make sure that your boundary groups kind of map to your physical boundaries of your network that you want to peer-to-peer within. Otherwise, you can end up dragging content all across the world. Watch out for overloaded super peers. This gets some people who have relatively old desktops that are not too beefy, and if you have a ton of machines trying to get content from a super peer, then it can be quite resource intensive, and there are triggers, there are thresholds within that say if it goes above a certain CPU level, then reject query, reject the request for content. So you can end up with your requesting clients going back to the distribution point because it can't get content from the super peer because it's been rejected. We have a free tool on the website that you can use to tweak those settings, and the three main settings that it uses are CPU, disk, and low battery level. So if for instance your super peer is a laptop, which we don't necessarily recommend, and it hits a low battery state, then it will start to reject requests. Use phase deployments to seed content to super peers is a really good way of improving the performance of peer cache, because if you think about it, what you can do with phase deployments is you can say only deploy to collection B if everything in collection A already has that content. So if collection A contains your super peers, then you can make sure that that content is fully downloaded before you move on to deploy it. And as we mentioned, you need to have all of that content in CCM cache before that can happen. Monitor with client data sources dashboard, we've already mentioned. Start small and test. This is really important. Lots of people just turn it on and think it's just going to work out the box, and that's never a good idea really with any config manager component, as you know. But really the last point is probably the second most important, and it's always back up Pete with Bob for max P2P. And the reason for that is that config manager will always try peer cache first if peer cache is enabled, but then it will fall back to using branch cache. So if you've got a peer cache super peer that gets the content but then gets switched off or whatever, you can still branch cache. So why would you not turn it on really? Use both. If you absolutely want to use peer cache, then you should 100% use branch cache as well, because it can also cover the gaps and things like policy and scripts. It can peer-to-peer that content as well. I think that about covers the best practices. Amy, this is your slide. I know you're very proud of it. And
Marriage. Okay.
Very appropriate.
And this is just a little bit of what we talked about. We have resources available at the end of the deck as well. It'd be a little bit pointless to read through a table with everybody on the webinar, but this is stuff that you can take home as you're starting to plan your deployments and figure out which technology you want to leverage the most, or if you want everything to work together. A little bit of a summary here, and there's also more details, like I said, towards the end. And then comparing branch cache and DO, which we really haven't done yet, so I'll hand that back to Andreas.
Yeah, so basically, typically a lot of people compare these two, and they're like, well, we're going to, like, which one should we go with? Which is not really the right way. But this is more of a comparison around where the technologies are, not which one to use. So branch cache has been around for a long period of time. It works on any operating system, including Windows 7, 8, which delivery optimization doesn't. It works in any disconnected mode, so in secure environments with no internet access, etc. It's extremely well documented, even though it can be hard to find that documentation. It is one of these open standard protocols, so the protocol itself is actually documented. Then, as you say, it also has an HTTP integration. So if you are an enterprise, you can actually use it to speed up your SharePoint and other things that you might have in-house or in-house web apps, etc. Meanwhile, delivery optimization is more of a, it kind of came about as a consumer technology to help with Windows Update on the internet, etc. For downloads of the store and the games, etc. So basically, Xbox that if you download the game from Xbox is using DO to pull that down. So they have a lot to learn about the enterprise sort of that you guys run and manage, but they've done an extremely good job over the last couple of years to adopt, because take for granted, I've been doing this for about 20 years and I still learn things every day about how to do things. So it's interesting that they will have to, within a much shorter time period, learn, but also code these changes to make sure it works for all different scenarios. But what we recommend most customers is to learn both of them and to basically implement both in their environment, because they do two very different things. So then a lot of the stuff that like the little command line tool that you saw in the beginning that was visualizing the download was one of the free tools that we did very early on. And that had a back end where we basically fed that to a SQL database. That didn't work. It was kind of buggy, and we've basically taken that off the web now. And instead, what we'll be doing is to move all of our free reporting into Stifler Visualizer, which is a read-only version of the Stifler product, which allows you to do what the bits and branch cache reporting toolkit did, but in a real time, as well as together with the database format. So that's coming, and I think we do have a bit of a demo of that. Do we?
I have a little video.
Oh,
Yeah. Would you like to see it?
I would like to see it.
Awesome. I'll hit the button and count to 10. Are you sure you want to share? Not really, but I'm going to do it anyway. Okay. And I've lost my taskbar. Thank you very much, Windows. There we go. So this is a little snippet that I made earlier because delivery optimization was being quite painful. So this is Stifler Visualizer, and it's exactly the same as the full version of Stifler, but obviously it's read-only. So there's a server component and a client component, and the client reports into the server component, and the server component squirts all of that lovely peer-to-peer information and a lot more into these dashboards, so that you get a almost real-time view of what's going on. So the visualizer, like the read-only version that we're about to release, is it's really just a really quick overview today, because we've got another webinar in about a month's time, which will go through all of this and a lot more in detail. But this is just to kind of highlight what you might want to use it for. And really that is initially certainly using it for testing. So this dashboard here is a view of a subnet with some clients on it. And this is one of those clients. I've speeded it up a little bit so it's not too boring, hopefully. But we're going to download this game, Roblox, and this is client number 1. And what I was doing here, what I was trying to do is to test delivery optimization on this network. So here the client, the Stifler agent in the background has picked up the delivery optimization job, and you can see that little yellow stick there on the right hand side. The chart has started moving, so the client is reporting in, and that little stick is actually the hash coming down from delivery optimization. And once it gets the hash, it goes, okay, there are no peers, so I'm just going to download this. So that yellow block that you see moving there, that's the content. And over on the left hand side here, if I can actually roll the box around it, this is the speed at which it's downloading. So it's quite useful to see how much bandwidth it's going to use when it's downloading. And what you'll see here, and this is a 10 meg link, and you see how that yellow little block steps up bit by bit, and that's delivery optimization going, oh, I can use this much bandwidth. Can I use a bit more? Can I use a bit more? And what it does basically is it uses as much as it can. So it used 10 meg for that download. And so for client number 2, what we want to see really is it using not so much of the WAN bandwidth, hopefully. So client number 2 comes along, and you'll notice it takes a little bit longer to start. So users probably going, it's not so great here, but it soon gets going, because what's happening here is it's going off to the cloud service and saying, I need a list of peers that have got this content. And the cloud service is saying, okay, there's somebody just downloaded it on your network. So you can see there, it's going really quick. And the reason for that is it's getting all the content from its peer, obviously. Not a perfect demo, but I thought I'd just throw that together. It's almost over before it began. But so you got the little blue bit of content in the bottom right of the screen there, and that was the peer-to-peer traffic. So what we do in this dashboard is we highlight delivery optimization in yellow and bits traffic in orange and branch cache peer-to-peer traffic in green, or DO traffic in green in this dashboard. So this is just really a little bit more of the detail that we can get, so we can actually identify individual jobs you saw there. This is more of a traditional bits and branch cache download. So obviously we monitor all of these technologies, right? So we don't just want to monitor DO in one screen and bits in another. So we can actually monitor everything in one screen. And if we actually go back a little bit to about here, what you can see here, this is a delivery optimization download in yellow, and what happens here is that DO is basically hogging all of the bandwidth until that download starts to fade, it starts to get to the end, and then bits takes over. And so as I mentioned, DO is quite aggressive, but it illustrates quite well. And the green at the bottom there means that it's getting some content from branch cache. So you can see that DO is quite aggressive if it's left unchecked. And in the full version of Stifle, obviously we throttle and control all of this bandwidth. But this is just kind of read-only version that tells you exactly what's being used out there. So this is going to be available for download. I'm just going to move it on towards the end. You can see this is what we really want to see, is lots of green content. So this is kind of demonstrating the beauty of pre-caching content for branch cache purposes. And this is a software center download. So over here, again, on the left-hand side, you can see it's using nearly 45 megabits per second of peer-to-peer traffic. So it's just getting all of the content from branch cache on one of the other config manager peers. So that's pretty much what we want to see. So that was just a really, really quick overview of Visualizer, but we'll talk a little bit more about that next month. I think we've just got a couple more slides. So anyone who's still with us, thank you very much for staying with us. And now we'll hand back to Amy.
I think I'm having some technical difficulties again with the slide deck. So let me reshare it from.
Well, it's behaved quite well so far.
Yeah, just gives you this option to resume the slideshow, and then it doesn't. So anyway,
there we go.
There it is. Resources. So this is what what I was talking about just a little bit ago. We've compiled some resources from other presentations, but again, there's no merit in me reading this to you, but here we have everything kind of tiled together, so you can have a little bit more of an understanding, and obviously you can ask us questions about this offline if you need to as well. Some key takeaways, again, you are already using delivery optimization unless you've blocked it. Branch cache is not new, and it's also not going away as far as we know. You can use branch cache for both on-prem and as well as cloud content, as Andreas explained, with sideloading your Apex packages. And hopefully DO will soon replace bits and branch cache in the long term, but we're talking like
Yeah.
when we're ready to retire.
We
and our
did
children
think
take
it would have already happened by now when we were being foolishly optimistic when we first started working with delivery optimization, but then it became apparent that it's complicated, as are many things in the field that we work in. So yes, it will come eventually. Branch cache isn't going anywhere for a long time. Incidentally, just to mention, branch cache does come into play with cloud distribution points. So if you're thinking of moving all of your config manager infrastructure to the cloud, then you can still branch cache your content. Worth knowing. Sorry for interrupting, Amy.
No, you're fine. And although we didn't really cover lead-bat in this presentation, it's something that you should be investigating and starting to turn on in your environment. It's not a peer-to-peer technology, it's more of a congestion provider. So it helps coordinate what's going on your network. We do get some frequent questions. This would be more of a slide for Andreas or Phil.
Yes. Branch cache is not working. Why would that be, Andreas?
Most of the time it's actually down to different policies enabled on the machines. That's typically the number one thing. If you are on Wi-Fi, it could be, for instance, that the actual Wi-Fi access points are not forwarding any multicast and you're trying to use distributed mode in branch cache, which will block that at the access point level. So you won't be able to get anything down there. And switch storm control, I think, is for very big companies that have several thousand machines on the sort of the same switch port where they configure their like Cisco switches. It's not limited to Cisco, but they have a very default, a very harsh limit on multicast traffic per port. And when they see more traffic than that, they basically, the default option is to drop the port rather than just drop the packages, which could lead to people not being able to connect to anything. And then they call the help desk wondering what's going on. But I think, as far as I know, that's only happened once. So it's not too bad.
Not that common, but not great when it does happen.
Some additional references for people who like to be extremely technical.
Well, this highlights an interesting aspect. As you can see, more or less the actual interfaces that DO are publishing is built to replace bits. So ultimately, if your third-party app is built to use bits to create jobs, ultimately DO will create those jobs instead. So you think you're talking to bits, but you're actually talking to DO, which kind of puts the presence of where Microsoft is going on this on their roadmap. As you see, yes, they are looking to replace bits probably within the next 5 to 10 years. What's this, Amy?
So this is, if you didn't get enough out of this webinar and you want to learn more, we do have links to sessions. DO was covered pretty heavily at Ignite. You can get resources at the TechNet docs, aka MS WAS DO, or you can watch additional sessions. And we also have branch cache sessions. And it's important to note that even though these two sessions have the same title, they are not the same. So start with one, watch the other, and just keep repeating until you understand. It'll take about 5 years to become a master.
At least.
That's it.
I do have a little, if people are still around and we want to do and there are questions, I got a little secret demo as well if you want to show. I think there are some couple of questions, good ones that are coming in. So give us a second to answer those.
I need someone to pick a number between 1 and 225.
It's got to be 42, doesn't it, really? The answer to everything.
42, huh?
Mm-hmm.
Okay, here we go. So this, of course, is for the webinar winner, Mr. Ulf Soderstrom.
Congratulations. Come on down.
Hurrah!
Hopefully you're on this webinar. Let's see if he's here.
And hopefully you want to go to MMS.
Hopefully you want to go to MMS.
Because you're going.
No reply from Ulf.
Oh, wait. Oh, we got a question from Brian Dam. Is he here? Oh, he said 42 as well.
It takes a while to get the questions to come in, so you have to
I see. Yeah, I'm just getting them now. Okay. Can we talk about dedupe and which peer-to-peer technologies it impacts? That's a great question.
All right, I'll publish that one, and I'll
Yeah.
say
Publish that
only
one. We'll
BC.
talk about it. You want to talk about it a little bit?
Yeah, so I got some slides on that actually. I made a blog article on that. Let me find that link.
You did. You made a couple of blog articles actually, but the
Recently.
short answer is only branch cache.
Yes. So basically, the dedupe service will calculate the heavy hashes on what's required for the server infrastructure.
But only the file hashes, right?
Yes, but that is that's basically the heavy load of things. Meanwhile, the segment hashes or the segment secret hashes is only like 32 bytes with 32 bytes to hash, which is a tiny calculation. Meanwhile, the file could be 300 gigabytes, and then you still need to calculate each segment hash in that file, which is the heavy part of the calculations. And that's what dedupe does, because that's the same way that dedupe is building its own internal database of where the hashes are or how the files sit together.
So we always recommend that you enable dedupe if possible on your distribution points. There's plenty of articles out there how to do it. Just basically aim it at your content lib and off you go. But it can, on a really busy distribution point, it can make a big difference. And you can actually see the number of times that the dedupe hashes are used, and there's a perfmon counter called something like number of hashes retrieved inline, and that is actually the stuff that comes from dedupe as opposed to branch cache having to do it all itself. So you can monitor the performance a little bit with perfmon on the server side on the branch cache kernel mode performance counters.
Yeah, so we got a couple of good questions. One is like content library. If you want to remote DPs and SMB push, can we enable branch cache for SMB and help with WAN traffic when packagers? So the answer is basically no. It has to be coming from that. You can't push with branch cache because it's basically a caching on the intelligence on the end which is requesting the content. If you're pushing it up top end using SMB or bits or HTTP or whatever, you can't use it unless you reverse it, which is a complicated topic. But basically, if you're pushing things down via the SMB protocol, none of that will actually be used. So you have to initiate the copy from the actual peer, in this case, your remote DP, but there's no API to do that. So hopefully that answers the question. There's a lot of good questions. So meanwhile, we'll answer those for those that don't have anything better to do. Let's see if I can do a little demo. So we did have a question, Shay, what's coming in Stifler 2.0? And it's a little bit to answer about the whole thing of dedupe and how that sits together. So let's see if I can share. So of course we'll jump straight into Visual Studio, right? So I've got here a command to show, which can actually go to the database, the branch cache database, and query where within a file we have segments. So in this case, it will break the whole, it will break the whole file into 100 different chunks. So it will basically do 100 report chunks, and each segment has 5,000 or 50 segments. So totaling in 5,000 segments. So that tells you it's about 400 megabyte. And this case, it's an actual boot WIM file that we're going to report on. So Stifler will be able to tell you, even before you distribute something, if how much of this is available per client, i.e. totaling all of your machines within a location, how much is already pre-cached. So in this case, you will see that there's nothing out there. It's all 0, 0, 0. So far, so good. So let's stop that and we'll download another WIM file, not the one that we queried, but its little sibling, basically. So as we download that, you should be able to see it's basically pulling it down as we speak. So the one transferring here, that's basically what we were going to go and query here in a little bit. Takes a while. Let's see if we can speed it up. Or we can probably start querying actually. So as that one is downloading, we'll go back to the code and we'll go and run another query. So it looks slightly different now, right? So I think in this demo, I actually made a mistake and pulled down the one that I was querying. So you can see it's actually pulling 100%. So let's see if I can stop this. Probably going to turn into the most confusing demo ever. All right, yeah, I pulled down the wrong file. So as you see now, 100% is now cached, right? So that was a bad demo. I took the wrong file. So let's reset everything and do it the right way.
Don't you love live television?
Do it live.
I wasn't meant to demo this. I thought it was a good, interesting. So this is the guy we want to do. All right. So everything's done. Let's do this. Reset my 2 jobs. We got nothing in the queue. We're pulling that down. Going to monitor as it comes down. Oh, we didn't start it, did we? No. Oh, that's why. All right. Sorry for the confusion here. Let's see if that goes then. All right, so that's transferring. So as that's going, if this was the previous file that we downloaded, if you ran the reporting, we'll see that the actual chunks that we get back looks very different. So we haven't finished the download, but we can still see that the way that it's broken down into these chunks, we can see that we have a lot of this data already available locally. So we will be able to tell you exactly how many bytes will be required to pre-cache things out into your enterprise. Not only that, we will also be able to tell you exactly how much of package ID, CN0001 is available within any given subnet or location. So it's a pretty good way to manage the cache because you can start pre-caching content automatically to spread it out over a large number of clients. And the way that we'll do that is if I stop this and see that, so now we've transferred everything, right? So if you now rerun exactly the same thing again, you can see that a large proportion of this file has already been taken down. You can see each segment basically reports a pretty good chunk of contents. You can see here in the end, we're missing 100%. The last percent, we only have 7%, etc. So if you were to pre-cache things, which you can kind of do today in our tool set, you can use your regular command line tools to do this. So what I'm doing here is creating another job, which is pulling down the file that we're actually querying about. But we're pulling down only a segment in the middle. So I'm actually going to change that and say we're going to take the first 100 megabyte and pull down. So I want to do add file with ranges. I think that's the command. You can see I'm an old school guy using the good old bits admin tool. But in here, there's a tool to add a file. And you can actually give the range where in the file we should download it. So if I find that. Where is it? Am I blind? Oh yeah, here. So this is what you want to do. You want to create a bits job, but then you could split it out per individual machine. So you could use the fast channel in Configuration Manager or any way to create a bits job using the bits admin tool or the PowerShell commandlets, specifying out which chunk should go on which machine. So in this case, I'm going to say that this job basically is going to go, we're going to take the first 100 megabyte, but nothing else. So we're taking that, creating a bits job from it. And you have to use comma and not. So you see we added it with the range. And if I then start that, it's going to go ahead and download it. And then I can monitor it. You can see it's already transferred. And if I then query for this content, which will basically be our reporting, you can see that the first 100 megabyte, we have 100% already cached. So it means that we can, in a much better way, utilize all of the machines in every location, spreading the content out, and we don't have to have a single file present. Like if you've got a big WIM file, we can split that across any number of machines, etc. So hopefully that demo wasn't too confusing. Probably was. Do we have any other questions coming in? So did everybody fall off the bandwagon? Nobody here?
Still one or two questions.
Sorry, I was on mute. I was talking to myself. So, yes, Mike Terrell says, can you show your utility for migrating content from other caches to branch cache? No,
Yes.
sorry, Mike. Oh, yes, we can.
I think
There
I
is
can, actually.
There is yeah, well, I'm sure we can. There is a blog coming soon. And all of the relevant stuff will be going on to GitHub. We've been testing that quite intensively this week. And what Mike is referring to is...
I actually got a demo.
Yeah, I'll just explain what it does
Yep.
while you do that. And what it's going to do, what we're talking about here, is taking content from other sources and putting them into branch cache. So, for instance, if you wanted to take everything from your CCM cache on a machine, you've been downloading content, but you haven't had branch cache switched on, you can take your content from all of your CCM cache folders and put it into branch cache. So then you can you avoid re-downloading that content. You can pretty much take any content you like. So you can migrate from other content providers. So if you're currently using 1E or Adaptiva, you can migrate that content into branch cache. Sky's the limit, really. You can do it in an offline media scenario. So if you want to stick a USB in a machine, run a task sequence and pull lots of content from the USB into branch cache, then this little utility will do that. And I think Andreas is going to demonstrate that exact scenario.
Yeah, so what I got here is a little task sequence. It's not really important what's in it. We're running a PowerShell script, which is basically calling one of our free tools, which will talk to the branch cache API. So what I'm going to do is to jump to a machine that I can show this running on. So yes, updates. So if I were to take my client here, I can basically inject this as an ISO. So what I do is I export it as a standalone offline task media. And if I, let's see if I can, come on. No, it doesn't want to go full screen. All right, let's do this then. So what I'll do is I'll flush the cache here. If I can spell, and then I'm going to kick off my little configuration manager task sequence. It's not much in it. It only has my script, a couple of reference packages, any number of packages you want to reference. So you can run it as an ISO or a USB stick or whatever. But ultimately, that will then start, and for each package that is referenced, it will basically inject all that content into branch cache itself. So it's a good way for technicians, if they go to a site or whatever, they can have their latest and greatest with them on a USB stick and inject that onto a single cache machine. And the nice thing is that we'll integrate that with the whole spreading of content that Stifler will do. So Stifler will tell other machines to go and get little bits of this and then spread that onto other clients. So you saw that complete there. And if I scroll up here, make this a little, oh man. You can see our patching strategy needs help. But here, if I do this, we can see that we've injected about 3.6 gigabyte into, or 300 megabyte, because the injection is not that great, the file that I have, into the cache. So it was empty from the beginning, and then I ran my little task sequence and injected 300 megs. So it's a pretty neat little feature of that. Basically, what does the job is two things. So let's see if I can zoom in on this. Zoom, it's not playing ball. But basically, it's two pieces. It's the branch cache tool, which is executable that has the full branch cache API, and a script that basically parses and goes through all of your different folder structure, making some intelligent decisions whether or not it's worth injecting, etc. And then running our command line tool with the right parameters. So it's pretty big, but it's coming onto GitHub. So we're moving all of our script bases now up to GitHub, so you can get all of it from there and download it. And the branch cache, all of our binaries will probably be dual hosted both on GitHub as well as on our website itself. The same script can then be used also in a task sequence where you want to inject regular packages. So maybe you don't want to build using peer-to-peer, because you want to build as fast as possible, and you've got a local good server that you build from, but you don't know where the client's going to go. You can then inject all the packages after the sequence completed to avoid having basically creating a cache to avoid wide area network traffic as much as possible. So lots of good questions coming in, which
Best tip of the day actually from Adam Cook just came in. In your command console, type mode 200. I did not know that.
which does what?
Try it and see.
In a regular command prompt?
Just open up a command prompt and type mode 200.
Oh, very nice.
There you go.
Somebody give this guy a pass.
Shh,
I know.
it's not that good. I will use it every day.
Does it work on my Windows 8 machine though? That's a good question.
Who still has a Windows 8 machine? Come on now.
It does. How about that?
Does? There you go. Yeah. Any more questions?
Yeah, there's lots of questions. So if I enable dedupe on the scale out file server, can I dedupe a second time inside a VHD running? Yes, you can, because it's basically per data blocks. And basically the VSS just has a database linking all of the hashes that are the same across multiple files. So you might not store any data on the softs, but you'll store data on basically pre-calculating in the hashes. But if it's only to save files, save data, you won't actually save anything with storage on the softs blocks. So Marcus de Grahamas is saying you can also pre-create the v-hashing. Yes, you can indeed create both v1 and v2 with the pre-caching script. The other question was regarding to use bandwidth, I think, or maybe someone's grammar.
Oh, I don't know what that one is. Yeah. Question from Rick. Adaptiva advertises that the product can be used to remove all of your remote DPs. Is branch cache with leadbat or peer cache plus branch cache with leadbat mature enough to be at this level to remove all remote DPs?
I would say yes.
Yes. If it's
Depends.
set up correctly.
And also depends if you're looking to do like building with, if you have a Pixie service point today, then you would have to go with like our third party or someone else's third party Pixie solution to solve that, to do it on peers, because there's nothing else that will do that. I mean, but so that part you would have to fix. So the user state migration, people tend to not use that as much when they've gone to Windows 10. So that is less of an issue. So question, if you use pool DPs, can we use branch cache and to get the threads up? And I think Marcus there, Gramaeus, has spent quite a bit of time trying to explain that to customers, that yes, you pool DPs, which is using bits and branch cache, can then do the great delta of content on the packages that they pull down.
Yes, pool DPs with branch cache enabled are great, basically. And if you throw leadbat into the equation as well, then you've got full kind of bandwidth control as well.
So content library, remote DPs and SMB transfer. Can we enable branch cache for the SMB and help with branch transfer? I thought, didn't we already publish that? Maybe I thought I published it. I must have published something else.
I don't know. It's there now. Yep. So remote DP, yes.
If you only want to debuff content that is requested directly from clients, or you only want to dedupe content that is requested from clients, if you have pool DPs, would that not be considered client pooling data? Yes, it would.
Yes. Branch cache for SMB is actually not that great. We had an enormous thread years ago with a guy that was trying to do that kind of stuff, like doing a massive WAN backup using SMB, and
I'm not sure what he ran into though, but his data, he was basically trying to do 1.5 petabyte.
Yeah, it was more of a scalability thing, I think.
I think so. And there probably would be things depending on how he packaged it up. Knowing what I know now, I would have very different questions for him.
Yeah, but also there's things to get it working, like the SMB on the server side of things, like the client side caching and stuff. It's just a pain to enable on servers anyway.
Yes.
So I would definitely recommend making it a pull DP instead.
Yeah.
And then you get full deduplication on the wire. So yes. Okay, we have no more questions.
No more questions to
Everybody
answer.
go home. It's Friday. Hope you found it useful, everybody.
More.
Oh, not another one. There's always one.
So I really
just want to dedupe the content.
I
really want to just dedupe the content library so there is less data going over the WAN to the pull DPs. Yes.
Yeah, but you still have to. The pull DP has to be.
Yes.
Using branch cache.
The key to it is the pull DP has to be a branch cache client, and it's advised to make it a branch cache client in local mode, so that it's not going out and looking for content. It will be faster, basically. It's in
Yes.
local mode. But then you do get the full dedupe on the wire. So you get dedupe on the server side, but also only changes will cross the wire. So it's pretty efficient. But you can't just have a pull DP with bits on the other end.
We have more questions coming in. No, people saying thanks. Yes, thank you. When will a link with the recording be sent out? Yes, I believe so.
What about Mike Terrell's question about the script? We just demoed that, Mike. Mike Marable.
Oh, we just demoed that.
We just demoed that, Mike. Where have you been? Will a link to the recording be sent out? Yes. Thank you very much. You're most welcome. Hope everybody's found it useful. We're going to be doing another one in about a month's time, which will cover more of the OSD side of things. There will be a link to the recording.
And I think there will be a release of Stifler 2.0 webinar as well at some point, digging into that. So.
And there will be stuff coming onto the Git repository, so follow us on Twitter to find out when things happen. Basically, follow the 2Pint account or myself, Andreas, Phil, or Amy to keep up. Thanks very much to Amy for doing all of the heavy lifting and organizing this webinar and tackling the technology that is Microsoft Teams.
Yay!
Yes.
You still here? I thought you'd gone home.
Still here. Yep. Thanks everybody for joining. I'm not using this email list for anything, so if you want to keep up with us, you have to use Twitter. So thanks for giving your email address for the pool of tickets, but we don't need it anymore. Good day.
All righty.
Thanks everybody. Have a good weekend. Bye for now.
Bye.
Ciao.